Hello friends, my name is S.S. Benchali, Department of Mathematics, Basveshwara Engineering College, Bagalkot, Karnataka, India. For any suggestions, please write sbenchali@gmail.com. In this video, I am going to find the value of beta p comma q plus 1. So by definition, beta p comma q can be written as integration of 0 to 1 x raised to p minus 1 into 1 minus x raised to q minus 1 dx, right? So in this integration, simply I am going to replace q by q plus 1. So beta p comma q plus 1 is equal to 0 to 1 x raised to p minus 1 into 1 minus x raised to q plus 1 minus 1 dx. So this is equal to 0 to 1 x raised to p minus 1 into 1 minus x raised to q dx, right? So now I want to integrate by using integration by parts, right? I am going to treat 1 minus x raised to q as a first function. So therefore I want to keep 1 minus x raised to q as it is. Integration of x raised to p minus 1, I can obtain x raised to p divided by p with the limits 0 to 1 minus big integration of 0 to 1 x raised to p divided by p into differentiation of first function, right? So n into x raised to n minus 1. Using that formula, I can obtain, right, q into 1 minus x raised to q minus 1, but it is not x, that's why I want to differentiate. I can obtain minus times of dx. Okay, this is equal to, now I want to substitute the limits. When I replace upper limit, it becomes 0, 1 minus 1, 0. When I replace lower limit, in that case also, it becomes 0, right? So 0 minus into minus, it becomes plus. Integration of 0 to 1, q is constant, p is constant, therefore I am going to write q by p outside. Remaining thing is x raised to p into 1 minus x raised to q minus 1 dx, right? So now I want to substitute x raised to p can be written as x raised to p minus 1 minus x raised to p minus 1 into 1 minus x. So this can be written as q by p is constant, right? So the value of x raised to p can be written as x raised to p minus 1 minus x raised to p minus 1 into 1 minus x. This is the value of x raised to p into 1 minus x raised to q minus 1 dx under the integral sign with the limits 0 to 1, right? So further I can simplify. So q by p integration of 0 to 1 x raised to p minus 1, I am going to multiply into 1 minus x raised to q minus 1 dx, right? Minus sign, right? Minus sign with the limits integration of 0 to 1 x raised to p minus 1 into 1 minus x into 1 minus x raised to q minus 1. Base is same and I can add the powers. I can obtain 1 minus x raised to q dx. Is it clear? Right? So this can be compared with the definition of beta function x raised to p minus 1, x raised to p minus 1, 1 minus x raised to q minus 1. So this can be replaced by q by p beta of p comma q minus, so q by p is constant, this can be written as p comma q plus 1. Is it clear? So beta of p comma q plus 1. But what I want to obtain? I want to obtain the value of beta of p comma q plus 1. Left hand side is beta of p comma q plus 1. Right hand side is also containing the same thing. That's why I want to take this term to left hand side it becomes q by p beta of p comma q plus 1 is equal to q by p times of beta of p comma q. Is it clear? Right? So observe these two terms. What is the common thing? Beta of p comma q plus 1 is common. The remaining thing is 1 plus q by p is equal to q by p times of beta of p comma q. Is it clear? Take the LCM. Beta of p comma q plus 1 times of p plus q divided by p is equal to right hand side as it is beta of p comma q. Right? So now I want to obtain beta of p comma q plus 1 is equal to p divided by p plus q into q divided by p beta of p comma q. So p cancels with p. This is equal to q divided by p plus q into beta of p comma q. So this is the required value. So exactly in the similar way, if I want, I can calculate beta of p plus 1 comma q. Right? So thank you very much for observing this video.